So good morning everyone. We will again try to do a problem using your sequential thinking technique. So the problem given is a gas at a pressure of 101.3 kilopascal and a temperature of 20 degrees Celsius has absolute viscosity of 2 into 10 to the power minus 5 Pascal seconds and kinematic viscosity of 15 millimeter square per second. Taking the universal gas constant as 8314.7 joules per kg Kelvin, and assuming the gas to be an ideal gas, calculate the approximate relative molecular mass. So as usual, when we have to solve a problem, first thing we do is we write down the given data with appropriate units, and then of course also try to homogenize the units to the fundamental units. So let us first have this data. Pressure is 101.3 kilopascal, and kilopascal can be written as 10 to the power 3 Newton per meter square. The next value given is temperature 20 degrees Celsius, and in the absolute units it would be 293.15 Kelvin. The absolute viscosity of course is given as 2 into 10 to the power minus 5 Pascal seconds, which of course becomes 2 into 10 to the power minus 5 Newton per meter square second. And then kinematic viscosity of course is again given as 15 millimeter square per second, can be homogenized to give the unit meter, so it becomes 15 into 10 to the power minus 6 meter square per second. And the universal gas constant 8314.7 joule per kg mole. The unit can be normalized, and then it will become Newton meter per kg mole Kelvin. So then we write, we look for what is asked for, and then it's molecular mass, and then we write an equation for molecular mass. Since the universal gas constant is given, you write the equation as universal gas constant divided by the characteristic gas constant. Characteristic gas constant is not given. Obviously, we have to write an equation for characteristic gas constant. Using the ideal gas equation, we get R is equal to PV by MT. Now, when you look at this equation, P and T are given, but V and M is not given. Then we look at the problem again and find out that what is again given is absolute viscosity and kinematic viscosity, and we know that the kinematic viscosity is defined as absolute viscosity by density. So density obviously will become be given as AV by KV, and then of course we can write the equation for R as P by rho T. So all of them are known, and then of course we can rewrite the equation for mass as substituting all those values. Rho U, universal gas constant, into temperature into absolute viscosity divided by P divided by kinematic viscosity. So that equation now we have to substitute. So we will substitute both the values and the corresponding unit. So when you substitute for absolute viscosity, universal gas constant, we get 8314.7, and the unit is Newton meter per kg mole Kelvin. And then the temperature is 293.15, the unit is K. And then the absolute viscosity is 2 into 10 to the power minus 5, and the unit is Newton second per meter square. The pressure below now is 101.3, so the unit would be of course reverse of that, so it is Newton second per meter square, and the kinematic viscosity of course is Newton per meter square. I'm sorry, second per meter square. So if we cancel out, then we get the final unit as Newton second square per kg mole meter. Of course, then we also know this obviously is the final unit which is required. So we know that Newton, this force unit, can be converted into the mass unit by using this unit conversion factor for converting from mass to unit. So we substitute that. Then this Newton second square and Newton second square will cancel out. This mass, this meter and meter cancels out, and we get the final unit as kg mole kg per kg mole. So we have solved this problem. So thank you so much. We will meet again.